This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hello and welcome to the book club for March 27th, 2024. The month is marching on for sure. And we were just talking about the solar eclipse that is coming up. So just out of curiosity, just like, I don't know, raise your hand if you're going to be seeing totality in a couple of weeks. Yay. Is there anybody who's traveling in order to see totality? Jana, fun. Anybody else? I can only see like 3 people, so.
I'm going to Ohio, so there's not much chance I'm going to actually see it, but
Jana, I live in Ohio and I feel the same way. But we have family coming up from Georgia, so hopefully we'll see something.
yeah, fingers crossed. Yeah.
Well, I live in Indiana, and so apparently I'm in the direct path because even our grocery stores have T-shirts about Indiana being the place to be with the eclipse. So I plan to just be able to walk outside with my little glasses and see it.
Sounds
We're
great.
traveling from Georgia to Arkansas to see it.
It's worth it. We lived in California during the last one, so we drove up to Oregon, and it was amazing. Like, it's so worth it. And don't get caught thinking that 99% is just as good as totality, because there's nothing alike. So just in case you're like in the 99%, it is worth driving in to see totality.
What's so neat about the eclipse in totality is that if you're any place rural, you can just feel this weirdness. It's like the crickets come out and the cows start mooing and laying down, and I remember being able, it was almost like there was a circular sunset all the way around. It was beautiful.
We actually drove south, I don't know, about 2 hours, probably the last time, in order to see totality. And we were fortunate because it had been very overcast, but it sort of cleared enough that we were able to see it. But I remember they were forecasting all this crazy travel. And so I've like found all these back roads, and we just picked a church in the middle of nowhere and figured they wouldn't mind us sitting in their parking lot. And so this time we're not traveling, but I figure it'll still be cool to see the shadow march across the sun over the course of a couple of hours. So lots of geometry and mathematics involved in that. So cool. All right, well, let us go ahead and jump in. We are looking at lesson 23 and 24 this week. And so seeing that on our map, and that's an important part of what we ask our tutors to do every week, is to take a look at that map. It may seem like, oh, I've seen that every week, I know where I am, but actually charting our progress is important. For those of you who don't know, I was in the Coast Guard, and so we used charts, we used maps to navigate. And when you're traveling a long distance, right, when you're going along, so where you are is by keeping a track, right? Every hour or so, you would mark on the chart where you are, so that at any point that's what my future track was based off of, was where I knew it at each point, whether that was going out and using something electronic, or whether that was shooting angles to the sun to get my local apparent noon, doing all of those kinds of cool things. Those positions were really important. We didn't just say, oh, we know we're in the middle of the Atlantic, right? We know where we are. We went in and we charted it so that we could actually see where we were on our journey. And so we encourage our tutors every week to pull that math map out with their students, to look at it and say, where are you? And so that's why every week of our book club, that's what we're doing. We're reminding ourselves that we are working through the naturals. So I am pulling out some questions and challenging you to think as though you're a dialectic student. But I really want to emphasize that we're using those naturals materials. And this week we are in 4D. We're going to be looking at 4D this week, and next week, intersecting spaces, and this week, matrices and rates. All right, so let's start here and give you a minute to look at the page if you haven't seen this before, and share what you might see that is familiar and what might be unfamiliar.
I remember
think
the
I
word
saw the
Tesseract.
Tesseract. Oh, go ahead.
I was just gonna say from Wrinkle in Time, wasn't it? One of the Wrinkle in Time books
Yep.
used the word Tesseract.
Didn't we see a version of the Tesseract in one of the Marvel movies, like when he's putting his hand through the screen and looking at it or something? Or maybe it was when they stole something that looked like a Tesseract.
I haven't seen that movie, so I don't know, but now maybe I'll have to go. You'll have to figure out which one it was. Maybe I'll have to go watch it.
Yes.
So something that is not familiar is MARP and GARP. Are those made up or are those real words?
We did not make them up. Somebody made those words up. And I'll point out that there's two other words that you're going to see in this lesson, maybe not today, but in this lesson called Anna and Kata. And if you look at this diagram where you see MARP and GARP, what are they analogous to? How would you describe them?
Ooh.
Well, I would go northeast, southwest.
Okay, so there's something in between. Good. So they're not actually going to be northeast because that would be in the same plane. They're going to be but let's go back to what you said about northeast, south, and west. True about northeast, south, and west compared to a left, right. What's
My
the
mind
difference?
is blowing right now. I'm sorry. Go ahead.
What's the difference between east and west and left and right?
Nothing really, right? I mean, that is
So which way
that
you're
is our left
facing.
and right.
Well, isn't east and west direction, and left and right might not necessarily be direction? I don't know. I guess it would be direction.
So it seems
Well, I
to
would say
be,
east and west don't change, but like my left might be the east, and then if I turn around 180 degrees, now my left
Right.
is the west.
Right.
Excellent, Nicole. So east and west, north and south are fixed directions. They're cardinal directions, right there. And I'm going to relate this to numbers, right? So when we talk about cardinal numbers, 1, 2, 3, and 4, right? One is always one. It's not relative to anything else. 4 is always 4. It's not relative to anything else. Ordinal numbers are put orders like first, second, third, fourth. So I'm going to write something on the screen here. Let me turn on my pen to annotate. So okay. In these two lists, 4 is always 4, 3 is always 3, 2 is always 2, 1 is always 1. When I'm talking about the cardinality, the size of the number, what it represents. The order of the number changes, right? So in my first line, my 4 is first. In my second line, 4 is fourth, right? So it's relative to other things. So that order is always relative. East, north, south, east, and west are called our cardinal direction because they're fixed, right? Just like cardinal numbers have a fixed magnitude, our cardinal direction is fixed. Wherever I am on the earth, east is always going to be east and west is always going to be west. right? And so when we look at MARP and GARP, we're defining them in a similar way, that MARP is always going to be in the same direction and GARP is always going to be in the same direction in 4D, right? No matter where I am in 4D, MARP will always be in one direction and GARP the opposite direction in that fourth dimension. If we were to look at our sort of our ordinal directions, right? So our relative directions, we're talking about left and right. We might say up and down, right? Up and down are hard because they can kind of mean both, right? It could be, if I'm thinking about cardinal directions, up is always away from the earth, down is always sort of towards the earth, or the center of the earth. But on a piece of paper, I could talk about the top and the bottom going up and down the paper, right? So they're a little bit weird, those two words. But Anna and Kata are in that same family, where Anna is going to be like left and right. Anna sort of means an up towards, and Kata is sort of a down away from. And but they're relative to the point of origin or the point that we're comparing, right? So they're going to be sort of this ordinal comparative relative word. So anyway, so unfamiliar words that somebody else came up with other than us, and they are words, but are the ideas that they describe, are they invented ideas, or or by us, or were they already there?
They were already there.
They were there, right? If dimension, there has to be direction in that fourth dimension, right? And so we're just naming something that's already there. And it just reminds me of a something I read or conversation. I think that it was in the thesis of one of our master's students, but I want to be careful in case it's not. But that's that idea that, right, is math God created or is math man created?
Definitely God created.
It's God created and man discovered in his
There you
search for
go.
God.
Yeah, we get to name the things, just like Adam named the animals.
Yes.
Excellent, right? So God created this world, and you're right. We get to discover and name things. Does that give you more confidence in studying math, that you're studying something that is sort of immutable, it's unchangeable, it's established, right? And so our understanding of things may change, but the fundamental ideas themselves are not going to. And that's important. You know, when we talk about the order of operations, it's inherent to the numbers themselves. It is not something that man came up with and said we're all going to agree. It's inherent to the numbers themselves. So, so just like this, somebody named Marp and Garp and Anna and Kata, not me, but what they're naming, right? That idea is there. So if we were to think about 5D, would we need another set of direction names? Yeah. And to my knowledge, there isn't yet another set of direction names for the fifth dimension or the sixth dimension. So there you go. Your kids could like decide to name something, right? They could claim it, go out and like stake their claim. I'm going to name these directions in these other dimensions. All right. Great conversation. All right, I'm going to go ahead and let's look at our next page. And I'll give you a minute to see if there's some things on here that look familiar or unfamiliar.
Well, the names additive identity and the property of zero are familiar concepts from our memory work, even though maybe the bracketing is unfamiliar.
Good. Excellent. So
I
we're
know
finding,
go ahead, sorry.
you know, I was just gonna say, we're gonna find something familiar and then we're gonna connect it to something that's unfamiliar. So that was a great, great observation to say, I know of this, even though this other thing may be new. Sorry, Carrie, go ahead.
I was just going to say the matrix. I'm working through these pages with my soon to be challenge A student, and the matrices are confusing. So even though we've seen them, they still are unknown on how to manipulate, and which one means multiplication, which one means subtraction. So that's still an unknown.
Right,
Because
sure. Oh, go ahead.
are we familiar with things like we do it once and that's it? We're familiar with it?
Mm. It does look like the distributive property happening like in the middle section there. Like you
Okay.
can see the 3 is outside the brackets, and then you're multiplying it by each of the numbers inside, both the vertical and the horizontal.
Okay, good.
Yeah, Timothy in the chat said the matrices look like the distributive law at work. That was a great description.
The ones that are within the straight lines, like absolute value, are actual determinants, and those are special types of matrices that have values, numeric values.
Good. So Melba is pulling in some information there. So, and I love the fact that you said it looks like absolute value, because it is called the determinant. But when we talk about absolute value, so think back to 1D, and we talk about absolute value. What is absolute value? What does it tell us?
Distance from the origin, maybe?
Okay, so if it's a single number, it might mean our distance from the origin, which is the magnitude of a number. Right? So that's my magnitude of a number. It's telling me my size. So good. So it's in 1D, when we're thinking of numbers, we're thinking of distances, we're thinking of magnitudes. How about when we talked about sets? So going back to 0D, when we talked about sets and we saw that same absolute value notation, what did it mean? Anybody remember?
The number of items in the set? Or...
Excellent. Yes, the number of elements in the set. So it told me how big, the size or the magnitude of the set. And so here, what is our gut sense when we see that notation, and we may not know what determinant means, and we may not know what it means to find the determinant of a matrix, but when we see that notation, that absolute value notation, what's your gut sense that it's going to tell you?
It's just that number? That's my gut says. Just repeat that number that's inside the box on the outside.
Okay, so but now I've got 4 numbers. So what do I do with those 4 numbers? What's it telling me? If it told me the size of a set, it told me the magnitude of a number, what is that notation always kind of telling me about something?
So if it's in its longer form, like at the bottom, are you asking like maybe it shows us the difference between these two sets since there's a subtraction?
So I want you to think less about matrices and just what that absolute value symbol might always be telling us about whatever we're finding the absolute value of.
The value of it, or the
It's distance from 0.
Telling us the magnitude.
Magnitude, right? So whether it's magnitude of a set, it's giving us some sense of magnitude. Now it's a little bit different with a matrix. But we're going to find that it's going to be related to giving us an area. If it had a 3x3 matrix, it would be giving us information about what kind of measurement do you think?
Volume?
Volume. If it was a 4x4 matrix, what might it be giving us a measure of?
Capacity, I think you called it.
I was going to say, I always have to look up to see if it's capacity or content. So I'm going to look that up because I want
We
to
did
say the right
your
thing.
last book club, you actually used both words, capacity and content.
So content is the 4D word, capacity is the general term.
Okay.
Okay.
So area, volume, and content would all be the capacity for their particular dimension. So going back now, if I had just one term, like 1 by 1, right? I'm in 1D. Does it make sense? It's giving me a length. All right. So I think this is, I happen to think this is really cool that when we take this idea of absolute value, that when we're kids, we just go, it just gives you the positive. Nobody, right? We tend to just teach that, but we see here, it's got this really like big meaning that when we see absolute value symbol, and whether we're putting it around a number or a vector, we're going to see in 2D with complex numbers, it's still giving us the distance from the origin. Um, and then we see here where we have our matrices, right? It's giving us, because it's always just with square matrices. So squares have areas, cubes have volumes, hypercubes would have content, and then, right, the words beyond that, I don't think have been created yet. I don't know what the 5D version would be, the super hypercube, right? I don't know. But that determinant is always giving us some idea of what that content, that capacity is. So anyway, I just think that's really cool, right? That this same symbol means the same general thing in all of these different applications of it. We're not redefining it to mean different things, even though it may be the language may seem different depending on our application. Anyway. All right, let's look at our next page. Okay, so I'm just going to ask you questions this time. And I'm going to ask you what this page at the top, it says linear systems with matrices. So I want what 3 expressions at the top of the page make up a system? What do you think makes a system?
Well, usually a system is when you're given multiple, well, these aren't equations, they're expressions, but multiple expressions that are related to each other.
Good. So if we look here, we see we've got 1x plus 20y plus 30z, 0x plus 1y plus 12z, and 0x plus 0y plus 1z, that together they can make up a system. What's the highest exponent in that system?
1.
1. That's what makes it a linear system. So when you see those words, linear system, what we're talking about is that my highest exponent, my highest degree is going to be a 1, right? And that this, like you said, the system is that there's multiple things and they're all in that same space. Now, the linear equation with 3 variables is going to actually define a plane. So we have 3 planes that are intersecting in 3D space here. That's what this is describing. Maybe intersecting, right? We think they might intersect. We need to do a little bit of work to see. But that's what I just wanted to walk through what that meant to be a linear system. Because that is one of the big applications of matrices. So you can see here, our youngest students really aren't going to be worrying too much about those definitions, but they're going to be gaining some familiarity with the notation, right? We're hoping that over time, we're going to make the notation more familiar so it's less actually start, right, understanding a little bit more.
I have a question. I know this is geared, this is for 5-6-year-olds. And I know the companion, we haven't been able to see the companion with how we teach it. But I mean, I've been teaching like algebra to my older kids, and will the companion tell me how much of that I'm not very familiar with teaching matrices, because it's higher level, and I know we don't want to go into deeper, but how am I going to know how to present it and to what extent I would want them, because I know they can copy it, and and I've been talking to my son, because when he goes through challenge A, he's going to go into a little bit more detail because he's not 5, he's going to go through the complex material. But I want to make sure that I understand it before I explain it to him, So when does that teaching occur to me?
So, so 2 parts. One, I think when you see the charts, that's going to give you a little bit of a glimpse of the end goal, right? So we're just gonna talk through it. So the charts are going to give you the big picture. This is all the grammar that's related to matrices and how we use them. And so that would be one way that you can go, okay, how does this fit in to what my end goal is for matrices, and seeing that. Then, yes, in the companion, there are attached to those charts, you can go in and say, okay, I want more of an explanation on linear system. And even though I am writing the content, I can't tell you if that's actually in there in that way. So I'm making something up that you may go, she said it was in here and it's not. It is in development, so I can always add things in. The first thing you might want to do is look at the glossary, and you might go, okay, I want to look at the glossary and see these words mean, and start building that vocabulary right through the glossary. But then and that's available through the companion, but also through the companion is I can go and look at those charts, and I can click on different pieces of those charts to get more of an explanation. So for you as a parent, right, they're going to be working through this comparatively, building the grammar, their dialectic skills to build their understanding. And then you as a parent who goes, okay, I just need a little bit more. That's where there's going to be more explanation. It's not going to tell you ask these questions. It's not a step-by-step process on how to teach it, because we're not doing didactic teaching. We're doing the classical learning, right? And so it's this whole idea of comparison. But there will be a reference there for you as a parent with more background to these ideas and examples to work through. And as I say that, this first year through, what we will be doing is having a little video clip for each of the problems on the tops of pages 1 through 4 that will explain. Over time, over the coming years, more and more of that will be accessible, where we'll have either in words or video to click on a problem and see how it's worked out. And that just is going to take time for us to build out in the companion. Does that help to answer your question?
I think so. I guess as homeschooling moms, I want to make sure that I know it all before I teach my kids, and I don't know matrices. But I know that I don't have to know it to teach them challenge A, because I don't believe that they are expect. I don't want to overwhelm my kid with something that they don't know. But okay, I appreciate that. Thank you.
Oh, you're welcome.
Well, I kind of have a follow-up question.
Sure.
I think I have a follow-up question with that, because like like I feel like I've missed a few of these, but I feel like I still always feel like I'm guessing. Like when you ask me a question about the page, I still don't feel confident that I'm like able to teach this because I'm still guessing as I'm learning. So even the question, what three expressions make up the system at the top of the page would be helpful for us to have to know to even ask that question. Like the questions that you're asking us, is there a place where we will have even like samples of questions that we would be able to ask our kids? Is that what the companion looks like?
It it is not, because we haven't there. The only place where there are sample questions on the invention page where we do have sample, I think. Now, let me hold that back because I think that is not there. That is for the tutors. Um, I'm at this point, I don't think I have put questions really anywhere in there. It's more of an explanation, sample questions. That is something that we can do, probably not on the first go round, but add in. But I want to encourage you all that you do know the questions, um, because they're, well, for those of you who have engaged right with those common topics, and I think we've been doing a better job over the past few years of really introducing the common topics to all of our parents. And so instead of maybe asking those questions there that I came up with, because I'm coming from a different background, I would say that as a parent, I would look at this page. And again, if I'm working this page with my 6-year-old, they're they're just going to copy and they're not going to think. They're just going to be doing it and they're going to be building their familiarity. And this is the first year of, first or second year out of 12. If I was looking at a page like this with my dialectic student, right, I might say, okay, so look at that top part there. Let's compare. It says to called numerals. So compare what's going on, what's the same and what's different between what's on the left and what's on the right. And then I would just let them compare that, right? And it's kind of like an Annie chart, right? When we're talking about an Annie chart, there aren't necessarily right or wrong answers because we're looking for the things that are the same, what are different. So in that case, your student might say, well, on the left, there's X's, Y's, and Z's. There aren't any on the right. On the left, there's pluses. There's nothing on the right. But the right has these like brackets on the outside. So the thing that's the same are the numbers, the position of the numbers, and that's really what's the same. So I don't necessarily know exactly what that's telling me yet, but that's really important to how do these two things compare? And I'm going to ask you just to give me, sorry, I love you too.
I think too, it depends on the audience, like you were saying, because like, so in the pilot for Challenge A, a lot of the only thing I ask is what is familiar and what is unfamiliar. And then a lot of times the things that are unfamiliar are symbols. And so I at least know the symbol, right? And so I think knowing your audience really helps with the questions you're going to ask them, because you're right. I wouldn't ask these questions that she asked because I didn't know the answer. So I would never ask that question because I wouldn't know the answer. So I think it's when we know our audience, we know we're going to be asking questions that we know the answer to, or the what is familiar and what is unfamiliar, and things that are unfamiliar, then we can kind of research together, go look in the glossary, go look in the charts, and kind of see where we can find information that's related to those. That's kind of what the way we've done it in community.
And I would just encourage you too to not feel like you have to teach it all the first year. I mean, especially, right? So eventually, 10 years from now, students are going to be in Challenge A that have been using the math map all the way through, and they're going to be really familiar with it, and they may be asking different questions. Next year, it's going to be the first year using this for most students. while there's going to be some things that are familiar, right? Like 4 times 3 and 3 times 4, those students are probably gonna be like, I know that. That is that, right? That's really easy. But in context, I don't know what that means. And that's okay because next year is it's a grammar year. It's a year to become familiar with an entirely new math curriculum, right? That in and of itself is going to take time, right? It's a different way of learning. I'm not going to be reading down, looking at an example, copying the example, and then trying to do a bunch of problems on my own. I'm going to be looking at things comparatively. And so it's going to take time to use those skills of definition and comparison in order to pick up that flow of working in a classical math curriculum compared to a traditional didactic math curriculum. I sat on a bus with somebody once when I lived in Florida. I was going to the homeschool convention, and we had to park a ways out and catch a bus to come in. And I was sitting with somebody, and she was literally like just coming because she's like, I'm pulling my kids out of school and I like don't know what to do. And I remember looking at her and saying, well, give yourself a year to detox from school and figure out what it means to be home together, figure out what it means to be learning together. What does that look like? Don't think that your first year you're going to suddenly like accomplish every academic goal. And so the first year of the math map is not going to suddenly like you're not going to learn it all, right? It is intended to be a at a time. And next year is going to be a lot of just how do I work through this classical math, right? Learning how to do math classically is job number 1. Then building my math grammar, right? I've got to build my math grammar. I've got to be able to know what these symbols mean. I'm going to be defining words, right? Can I read the math, right? So that's job number 2. And I haven't even done a computation yet. And so then I'm going to start going, okay, now I want to start really putting some things into context, right? I really want to encourage you to be patient this next year because a lot of it's going to be learning what does it mean to do math classically. And that may mean some days your kid's just going to sit there and copy, right? So sometimes copy work is effective and you might go, we don't really understand anything on this page, but we've got the solutions. And so I can have my student go and copy these things and really be attentive in learning what these symbols mean and how to read it. There is support. There's support there for the tutors to come and ask math questions. We're going to continue the book club so you can come and ask math questions. There's going to be explanations available to you through the companion. Those charts are going to be there to give you the big picture. But I really want to encourage all of you who are like, I want to do a great job, that you will do a great job. But doing a great job may just mean pulling back and going, what does it mean to do math classically? Because that's a new thing for all of us. So.
Kirsty, can I read something that's in the chat?
Yes, please.
I think this kind of sums up for me. I think how the conversation got here is Christina says, is the confusion also magnified by the fact that in our everyday experience, we don't typically think in a 4th dimension? So it feels weird because it's hard for us to think in 4D.
It is. It is. So it's hard to think in 4D, as Carrie said, right? Matrices, that's just a big idea that a lot of us are maybe never introduced to in high school. And so that's where I come back to don't stress over like understanding it all when it's still grammar, right? That we all have to be grammarians. And as long as we persevere with it, it will become it will become clearer and we will build that understanding. All right.
Well, I do have one question in relation to this being kind of a grammar building year for the math map. So for parents who don't feel like they need to take a grammar building year, like they're maybe on their last kid and they don't really feel like that's a priority, or like for me, I have a rising challenge A and I have a first year essentials who will be in his second year of essentials next year, but they have always done the same math almost all the way through, and he's actually ahead of her. So what would be the recommendation, since we don't have the years, you know, and he's already doing all this math, or for one of my community members who, like, her daughter's already doing like ninth grade math, and now we're asking her to do the math map at the complex level. Like, how do you recommend we respond to situations like that?
So opportunity for everybody to be doing the same math, even if they're not necessarily in the same domain. I would recommend, because you're going to be doing a lot in first year set, I would recommend doing the fractions year with your son, and then building up to doing complex and challenge A. So they're doing ninth grade math. I mean, we just talked about the fact that we're doing matrices here, and those families that have kids that are maybe in ninth grade math, I can almost guarantee that there's going to be a lot of concepts that are in the math map that they will not have seen before. Right. And it's going to be different, right? So there's going to be things where they're going to go, oh, I was already doing this algebraic computation and I'm not seeing it here, but I'm filling in all of these gaps in my grammar, and I'm learning about concepts that I hadn't seen before and maybe wouldn't have seen for several more years. So if you're graduating your student next year and you're like, we're happy, we're done, then the math map may not be for you. Although we keep getting families who say we're doing the math map with our challenge 3 and challenge 4 student, because our feedback, very small sample size feedback, has been that the students who have enjoyed the math map the most are the ones that have used it as challenge 3 and challenge 4 students, because it's been those dialectic Pentecost moments where they go, oh, all of these things that have been together before suddenly make sense. And so they've been really excited about it. But that's what I would say is that this is going to be so different that it doesn't really matter what you've done before. Nobody will be ahead and nobody will be behind. Everybody can jump in at the level that's available, that's either at their age or age. And then next year, the one that's for their age will be available and move through that way. That's what we're recommending. So, all right, so I am going to skip that page. I'm going to just mention that again here. So this year, as you can see, right? So if this is my first year essentials student, so if I have a student in essentials, I would work with them through fractions next year. The following year, they can either go rationals, reals to complex. They could jump into reals and complex, or if they're third year essential students this year, next year they'd be in complex. So I can go make this happen for any of those 3 students next year going into the age appropriate level. And similarly, if they are not yet in foundations, I would work on naturals this year, and then next year they would be ready for the age appropriate level here. And then obviously our challenge A students in complex. So that's how we're recommending families start this year that want to go ahead and get started and not wait for next year. That's what we're recommending. All right, we are going to go somewhat quickly through this one. this lesson is all about rates. And I think this is a great conversation lesson, a great conversation while you're doing things, because what are some common rates that you may use just in life with your kids?
Like miles per hour.
Yep. We use that one a lot, don't we? Miles per hour. What else?
Math problems per hour.
All right. Good.
The time.
Yeah. How many for each person?
Okay, perfect. So things that are changing in time or splitting things among people, right? Those are all ways that we use ratios and rates to look at things. How about non-standard rates? So think about, especially with your younger students, what may be some non-standard rates that you might use to help them understand something? Example, when our kids were young, right, an hour, 2 hours didn't necessarily have a lot of meaning for them. So we would use comparisons to things that did have meaning. So if they said, well, how long is it going to take us to get somewhere? We might say, oh, it's about as long as Mickey Mouse Clubhouse, or it's about as long as it takes us to drive to church, or it's about it would take us 3 times, right, going to CC 3 times, or going to CC and coming home again, right? So we would use things that they could conceptualize as our comparison. So does anybody else do that with their kids? What other things might you use to help your kids understand rates?
Well, for my little, I like to say, we'll go see Papa and Nana in 2 sleeps, after 2 sleeps.
Perfect.
If it is minutes, we have had them just count 60 that many times. Pass the time.
That's a very practical way of helping them understand time and getting them off your case.
Yeah. Keeps them busy.
Okay. And we all do that, right? We all, when we're thinking about things, right? Whether it's because we understand time, or, you might think, oh, I've got to go, I've got this much time before somebody comes home or before my guests come. That's enough time to clean the bathroom, vacuum the floor, and pop the ice out of the ice, right? We all do it where we have things in our heads where we compare how long does it take, dad to drive home from work compared to how long it takes for me to make dinner. Right. And so helping our students just to be doing those comparisons, that's what this rate lesson is really about, is all about comparisons. And so with our younger students, helping them to just start making those comparisons is going to be a big part of what we're trying to do. And so we're going to talk through the lesson. They're going to see ideas about constant rates and changing rates. And, so we may talk about distance and displacement versus and speed versus velocity. Does anybody know what the difference is between distance and displacement and how that compares to speed and velocity?
I just did this lesson with my son, and so the distance and displacement made sense to me because the distance is the actual line, the actual like what you have traveled. So if you get to second base, you have now gone 40 meters. But displacement is how far it looks like to me, how far you ended up from where you started. So you would measure that like as the crow flies from home base to second, and then you would, whatever that is, it's not exactly 20, but so those two, speed and velocity, I'm a little fuzzier on.
So speed is your distance over time, and velocity is going to be your displacement over time.
Okay, that makes sense.
Yeah, I think of distance and displacement too. If you're traveling So I'll relate this to the Barkley marathons, a very unusual instance where people actually travel a distance, but the distance they travel is through mountains. And so they're looking at an altitude in addition to a meters. And so they may not travel that far distance, but because they're going straight up and straight down, displacement is going to be huge.
That's great. It's a great
I have a
example.
question about this page. The graphic at the top has the vector symbol in
Yep.
red for the baseball, and it's on the bottom. Does that matter?
It doesn't. I
Okay.
think yeah, I don't think that matters. It's just there. I think it was just trying to give a visual for which word went with which idea.
Thank you.
You're welcome. So let's look just at the top where now we've looked at constant rates, and we can look at when we have more than one rate, right? Some different ways that we could go, right? And so are there any other ways, right? So we've got one way and then different starting points. We've got a return journey there and back. Are there other things that we could do if we wanted to combine different rates?
I think a practical application, if you look at different rates, is preparing a meal where different things cook at a different time. And so knowing that you got to put the turkey in, but you can wait until the last 30 minutes to put the sweet potatoes in, is a good comparison when we talk about rates.
I love that. That's a great thing. A lot of times we think about rates in terms of motion, right? So we could have our kids acting these out, but I think that's a great example of different rates where we all need them to end at the same time, but the arrows are going to have different lengths, right? As long as they all end at the same time. Or we might have something that all starts at the same time and goes a different distance, right? We could have things that are going apart. So here's an example where we can look and say, okay, well, here's some ideas. What can you imagine, right? So what can you think of? How else could you think of combining different rates? All right, and then changing rates. So let's look at this last page. How many of our rates are actually constant in our life? Kristen's like, none of them.
Time is actually a constant in our purview.
Yes, the time that we experience is. And then, but how about how things change in time? Are they very often constantly changing? Right? If you think about driving down the road, even if you have your cruise control on, is your car going at exactly the same speed?
No, you have to slow down when you get a slow poke in front of you, and you have to slow down to make a turn. And
Exactly, right? We're always sort of like, it's always sort of changing. Right? And so what would a graph of your speed look like, right? So now I'm for older students, one of the things I love about this lesson is that it's a great opportunity to look at graphs that are not XY, right? Because I can now look at t and then my speed, right? So my change in time, my change over my change in time. So I'm looking at a rate here in a y, and I'm looking at a t instead of an x. So I can compare. That's one of the great things about this lesson, I think, especially in those early challenge years, is it really is going to emphasize for students that our graphs don't have to be XY, right? That I can use any variable. All right. Is there anything on this page that jumps out at anybody?
That's
I
a lot
think
of bread.
It
I
is a
also
lot of
think it's
bread.
funny to watch rabbits multiply.
And
That's
I like
cute.
seeing the fish swimming upstream and downstream. Makes me think of when we studied Lewis and Carroll. Is that what they're called? No.
Lewis and Clark.
We just read Alice in Wonderland. Yeah, Lewis and Clark, they were going up
You're
the
just
Missouri River.
integrating it all. Yes. Well, and I don't know why, but when I had the opportunity, I'm from England, and so I have family over there. And so the year before my senior year of high school, a friend of mine went and stayed with my family in England, and we had train passes. And I don't know why it fascinated me, the thought of being on a train and moving on the train, right? And so all the different combinations of speed as you're moving on the train. And then you go around a corner, right? And that's a different velocity because my direction is changing. And so, yeah, I had, for some reason, that always fascinated me, trains and movement on trains, just like fish in a river that as they're moving. So there's a lot, I think there's a lot of imagination we can use in this unit with our kids. And that's our early challenge year kids and our late challenge year kids, right? That we want them to enjoy the wonder of mathematics and enjoy the fact that mathematics is giving us words to express that wonder, right? And so now they might know, right? Intuitively, they probably know that if you're swimming upstream or downstream makes a difference, but now we can give them the language to be able to communicate that and explore that idea with somebody else. All right, and so I know I went really quickly through that rates lesson, but we have a couple of minutes left before for any last questions. So Babs, is there anything else that's in the chat log that we want to address, or any leftover questions that people would like to have answered?
I don't see any in the chat.
Can you please put the graphic up with the release dates and things that you had and the recommendations? I was trying to screenshot it and my computer was glitching. Yes, thank you so much.
Oh, you're so welcome.